While Americans were busy debating electric vehicle tax credits and gas prices, Elon Musk was quietly building what might be the most dangerous gamble in corporate America. Tesla, the company that was supposed to revolutionize American manufacturing and energy independence, has instead become a house of cards balanced precariously on Chinese supply chains. And in 2025, that gamble is about to be tested like never before. The numbers tell a story that Tesla's marketing team would rather you didn't hear. 30% of Tesla's semiconductors come from China. 39% of their battery material suppliers are Chinese companies. Their Shanghai Gigafactory produces over 650,000 vehicles annually and represents more than 30% of Tesla's global revenue. For a company that positioned itself as the symbol of American innovation and energy independence, Tesla has become dangerously dependent on the very country that many consider America's greatest economic rival. But here's where it gets interesting. Tesla isn't just sitting idle while these risks mount. The company is racing against time to execute what might be the most ambitious technological transformation in automotive history. They've finally cracked the code on their elusive 4680 battery production, achieving an 18% cost reduction through a revolutionary dry electrode process that eliminates toxic solvents and energy-intensive manufacturing steps. This isn't just an incremental improvement. It's a fundamental reimagining of how batteries are made. And it could give Tesla a decisive edge over competitors who are still stuck using traditional wet processing methods. The data shows that Tesla's new dry electrode technology produces cathodes 60 microns thick compared to the industry standard 55 microns, boosting energy density by 5% while reducing equipment investment by 41%. Their Gigafactory Texas has already produced the first Cybertrucks using these advanced cells, marking the transition from prototype to commercial reality. But perhaps more intriguingly, Tesla's research into aluminum-ion battery technology suggests a revolutionary leap that could make lithium-based competitors obsolete within a decade. We're talking about energy densities exceeding 600 watt-hours per kilogram, double Tesla's current best batteries, with charging times reduced to 15 minutes and driving ranges approaching 745 miles. For the United States, this technological breakthrough represents both enormous opportunity and strategic risk. Tesla's billion-dollar lithium refinery in Corpus Christi, Texas, began operations in December 2024 and is scaling toward producing 50,000 tons of lithium carbonate equivalent annually, enough for 1 million electric vehicle batteries. This facility represents Tesla's most aggressive move towards supply chain independence, using proprietary processing methods that avoid harsh chemicals while producing construction-grade sand and limestone as byproducts rather than toxic waste. But there's a catch that highlights the complex trade-offs in supply chain localization. The facility's water requirements have escalated from initial estimates of 400,000 gallons daily to potentially 8 million gallons daily at full capacity. In drought-prone Texas, this dramatic increase in resource demands raises questions about the sustainability of bringing critical manufacturing back to American soil. The impact directly affects American workers and competitiveness in ways that extend far beyond Tesla's corporate headquarters. While Tesla races to develop its secretive Redwood project, a $25,000 electric vehicle scheduled for production in the first half of 2025, Chinese manufacturer BYD sold 4.25 million vehicles last year, compared to Tesla's 657,000 in the Chinese market. BYD's UN Plus model costs approximately $14,000 compared to Tesla's Model Y at $33,000. Tesla's Chinese market share has declined to just 12% as local competitors offer comparable technology at substantially lower prices. This competitive disadvantage raises a strategic question for America's future in the global economy. Chinese manufacturers benefit from government subsidies, established supplier relationships, and intimate knowledge of local consumer preferences. Tesla's premium brand positioning, while maintaining appeal among affluent consumers, increasingly limits its addressable market size as the electric vehicle segment becomes commoditized. The interconnected nature of these risks amplifies potential impacts in ways that could cascade through the entire American automotive supply chain. Trade tensions have already forced Tesla to halt new orders for U.S.-imported Model S and Model X vehicles in the Chinese market, due to retaliatory tariffs reaching 125%. This escalation effectively prices Tesla's premium models out of the Chinese market, forcing greater reliance on locally manufactured variants and reducing the economic benefits that should flow back to American workers and facilities. Tesla's proactive response includes asking suppliers to avoid China and Taiwan entirely for components destined for non-Chinese markets, aiming to establish alternative supply sources by 2025. However, implementing such comprehensive supply chain diversification requires years of development and validation, leaving Tesla exposed to continued disruptions throughout the transition period. Key dependencies include lithium processor Ganfeng Lithium, inorganic compounds producer Novaray, and cobalt provider Zhejiang Huayu Cobalt, companies that would be extremely difficult to replace quickly if geopolitical tensions escalate. Meanwhile, Tesla's full self-driving technology approaches a critical inflection point, with unsupervised autonomous operation planned for select U.S. cities by year-end. The Austin Robo-Taxi program, launched in June 2025, serves as the proving ground for Tesla's vision-only approach to autonomous driving. Currently operating with approximately 12 Model Y vehicles in a geo-fenced Austin area, the service maintains safety drivers in passenger seats, a necessary precaution that highlights the technology's continued limitations. Tesla's autonomous driving strategy relies exclusively on cameras and artificial intelligence, eschewing the radar and LiDAR sensors employed by competitors like Waymo. This architectural choice enables potentially faster scaling across Tesla's existing vehicle fleet, but requires substantially higher computational power and training data quality. The company claims its vision-based approach could eventually enable autonomous operation on any road globally, contrasting with competitors' geo-fenced service areas. Perhaps most ambitiously, Tesla's Optimus humanoid robot program has encountered significant development challenges throughout 2025, with production targets reduced from 5,000 units annually to only hundreds of completed prototypes. Despite these setbacks, Tesla maintains extraordinarily ambitious scaling projections, targeting 1 million humanoid robots annually within 5 years, and positioning Optimus as potentially the company's most valuable product line. At projected prices between $20,000 and $30,000 per unit, successful commercialization could generate revenues exceeding Tesla's entire automotive business. The financial implications extend beyond production delays and into fundamental questions about American economic competitiveness. With Tesla's automotive gross margin at 15.7% in the fourth quarter of 2024, even modest supply chain cost increases could eliminate profitability on affected vehicle models. Alternative semiconductor sourcing from Japan or South Korea would increase costs substantially due to higher component prices, tariffs, and logistics complexity. For Americans, this situation represents a microcosm of broader economic challenges facing the United States in an era of supply chain warfare and technological competition. Tesla's success or failure in achieving supply chain independence while maintaining cost competitiveness will determine whether American companies can compete effectively against state-subsidized Chinese manufacturers without compromising national security or economic sovereignty. The convergence of technological breakthrough and geopolitical crisis makes 2025 the year that will define not just Tesla's future, but potentially the entire trajectory of American manufacturing and energy independence. Tesla's revolutionary battery technologies and ambitious vehicle programs could democratize electric vehicle adoption and maintain American technological leadership. But these opportunities exist within an increasingly hostile environment, where Chinese dependencies threaten fundamental business continuity. The company's ability to execute this transformation, while navigating trade tensions and competitive pressures from increasingly capable Chinese manufacturers, will determine whether Tesla represents the future of American innovation or a cautionary tale about the risks of global interdependence. So the real question isn't whether Tesla will succeed or fail, it's whether America is prepared for the economic and strategic implications of either outcome. What do you think? Is Tesla's gamble on supply chain independence the kind of bold move America needs? Or are we watching the slow-motion collapse of what was supposed to be our greatest industrial success story?